Hi, this is Dr. Jabali, and in this video, I took a past IB exam papers focusing on multiple choice for topic 10.3, which is all about speciation. So remember to read the question at least twice or three times, as well as ABCD, because they can be very close in answers. So let's go ahead and start reading this information right here. So first, we have the fossil records show that the black bears increased size during the ice age. So during the ice age and the very cold weather, what happens to the size? The size increased. And then decreased in size when the warmer temperatures. And then somehow when the temperature dropped, they decreased their size. So somehow the environment is influencing which way we're going to do. Now, what type of a selection do these changes sizes represent? So we have allopatric, directional, disruptive, and stabilizing. Now, allopatric will be that because of a mountain, for instance, like a geographical situation, you have two different species. Basically, there are two different species because one species is going to be on the side of a land and the other one is going to be the other, and they're separated by that map or a mountain or ocean. And that's basically a kind of a separation and causing them to have two different speciations. So that wouldn't be considered as a temperature influence on the society. It's more of a land going on. Now, directional, disrupted, and stabilizing. This, if you remember, there's three ways, and we even have a graph for them. So, for example, stabilizing, that means they're stably means and their traits are basically right here in the middle. If it's disruptive, it would means that somehow they are in the extreme traits. There is going to be two traits in extreme and nothing in the middle. And then directional will be that one moment there will be a shift towards one side of extreme, and then the next moment it might be a shift and do the opposite. It goes to the other side. Now, out of these, the one that makes more sense about this, first the cold, they go in one direction, and if it's too hot, they go to the other direction, right? At one time, it's only this extreme, and the other time, it's only that extreme. So obviously, that is directional. Why would it not be stabilizing? Because stabilized wouldn't mean that there's only one type of trait. In this case, we don't. Sometimes they're big, this time it's small. So this does not work. On this, it says sometimes is this or that. Here in this graph, here is saying that they have just extremes. That means it would have been very small or very big. But no, here it says one moment is just big, and one time it's only small. So obviously, it will not be disruptive or stabilizing. So it's definitely B, which is directional. The next question he says what can lead to reproductive isolation after just one generation? So when we talk about generation, that means we're passing a gene to the next generation. This is the first, the second generation. Something's happened, it's going to the third generation. So we're saying that the word here can lead to reproductive isolation. That means no more reproduction, right? Because something happens. So after you go from the first generation to the second, right here, it stops. You don't continue the reproduction. That's what it means by reproductive isolation. That means there is no passing on to the third. That means here you stop passing the gene because there's something wrong. So we have polyploidy, increased mutation rate, change allele frequency, independent assortment of chromosomes. Now, let's start with the ones that make sense to be none. For example, independent assortment chromosomes, that happens every single time you make a meiosis. So no, that's normal. Change allele frequency, and that can change depending who's mating with who, and from time to time, you can change the frequency because let's say this guy is mating with this, and then they have a baby that is this, but then this mates with this, and then they bring out here this, and then this one is mating with that. So you can change the allele frequency all the time, and it still doesn't matter. You still are producing and passing generations as you go, so it's not this. Increased mutation rate. Now, mutation rate will cause in one or two, but it doesn't mean that it stops the generation. You can pass on the mutations to the next, third, fourth generation. It doesn't matter. Now, polyploidy. How would polyploidy work? Now, when it comes to polyploidy, this is what happens. Sometimes you will have a 2N crossing with a 2N, and you will get a 4N. If you get that it's even, that's totally fine. But if you do a polyploidy of a 2N crossing with a 1N, it will get a 3N. And if it's odd, that's it. That is the final one. And there is no generation coming after that one, because if it's odd, it cannot reproduce. So the answer is A. Next, the graph shows variation in beak size for the bird Zoospizes fortis on an island in the Galapagos archipelago. So here we're seeing relative beak size index and the number of birds. So just looking at the sizes, we can see that right here, the sizes is the most number of birds have, which is about 0.75. That is the biggest one. And we can see that at 1.5, that is the lowest. Okay, we kind of looked at it. Now, what evidence from the graph indicates that disruptive selection is occurring? So they want you to mention the evidence in the graph that disruptive selection. Now, what is disruptive selection? Disruptive selection, it basically means that in the graph, we will have both extremes traits, but not in the middle. So you have the extreme here and an extreme here, whatever it is. Now, does it look like it? Well, it does have an extreme right here. So it does kind of look closely. Let's see what we have. An intermediate beak size is less common. Yes, you can say it is less common. So we're still going to see the other ones. A medium beak size is most common. Medium would means that right here, it should have been a graph right here with the medium part, right? So no, smaller beaks are favored. No, because the smaller beaks would means that we have a lot more of these up. We don't have that. Larger beaks are favored. That's not true, because if it was only larger beaks, it would have been that all of these wouldn't be in one size all. So let's say the bigger size is this one, so it should be very large here. So it's not large here or large here. Remember that these are the smallest beak to the biggest one, right? Small or big. And you don't see graphs like these, so these two do not work. And the medium will be that it's in the middle somewhere here, so it's big, and we don't see that too. So what we have is a little bit of here, a little bit of that, which matches with it. So out of this, we have A is the answer. Next, how do the concept of gradualism and punctuality differ? Now, gradualism is this slowly they are converting. So let's put here like an animal is slowly becoming different, and then it becomes a square. So it's gradually. Punctuated will be that something happens and it completely stops this, and then you start a new one. So which one is like abrupt? It's the punctuated. The punctuated is like at that moment, so it can be a disaster that just wipes up everything and then it starts from scratch. Gradually, it's the slowly mutations or changes are happening as the time goes. So what's the difference between them? The time of evolution? Possible. See, because this one is very fast and this is slowly happening. The mechanism causing evolution, the mechanism is the same. You're changing the species. So no, the sequence of the evolutionary events, that could be also. So I'm going to keep it up here. The reality of evolution, no, the reality doesn't matter. So we're stuck between the sequence of evolutionary events and the timing of evolution. So which one is the biggest concept? Now, we know that the sequence of the punctuated is different than the gradualism. But what is the main thing about these two? These is about the timing. This one is very fast and this is slow is the biggest one. Because when you say the sequence just means that we're going from one species to another species, from one species to another species. So the sequence is about what? Moving from different species to different species, which is the same thing as mechanism. So C is off and A is the right answer. So when I say gradualism and punctuated, it's all about the timing. Next, what example shows disruptive selection? Remember when I say disruptive, that means you have basically to the extremes. So you can have the lowest and the highest, and you do not have anything in the middle. So giraffe neck have become longer over time. This is not disruptive, because that means you would have gone from something small and then you cancel and now you just have one type. So no. Medium-sized beaks in hummingbirds have decreased in frequency over time. Medium size, look, it says medium, and yes, medium, what happens? Decrease, makes sense. It decreases right here over time. That's possible. Now, the peppered moth became less common in polluted environment, and the peppered moth less common, it just means you are reducing. But we're reducing what? You don't have in the middle ground, so no. Human babies with very high or very low birth mass have higher mortality rates, which would have been saying that these guys, if all the ones that are very high or very low birth mass have higher mortality rate, that means the graph would look like this. Because once again, this is trying to tell you that there's no babies with high mass or low mass. So what kind of babies you have? You only have babies are in the middle, right? Because what? The low babies and the high mass, what happened? They're dead. So it's not this. The graph should be something with two lines. So make the medium-sized peaks, how many have decreased frequency, which is the medium right here, it's low. So the right answer is B. So it's very important that you know about disruptive as well as stabilizing and directional, those three types, as well as gradual punctuated, because these are the most common questions when it comes to this section. Now, natural selection can operate in different ways. What is the effect of disruptive selection? Can you see there's a lot of questions on topic 10.3 about disruptive, stabilizing, directional, graduated, and punctuated. These are the most common questions. So, eliminates the individuals with the intermediate forms. Yes, it's all about getting the middle form. The form's gone. Like I said, you have the extremes and the middle, it's always not there. So I would say A, but still, let's check. Eliminate individuals at the random regardless of their characteristics. No, it's not random. You can see it's always about taking the one in the middle. It favors individuals with intermediate forms. No, because if you did, the graph would have shown here, and that's not true. It favors individuals at the extreme of the range of variation in the characteristics. Now, here students will get stuck. It says one extreme. It's not. It's supposed to be two extremes. They want a lot of low, a lot of high. So if you said two extremes, then yes, then that would have been the right answer. But because of that one word that says one, it does not fall. So again, disruptive has to do with two extremes, not one. So it's not D, and the answer is A. So be careful with the wording. Next, the cheetah is a large cat found in Africa. It has been discovered that organs could be transferred between any two individuals without rejection of the organ. Interesting. What is the probable reason for this? Now, why would they be able to transfer an organ between two individuals without any kind of reduction? Cheetahs have a poor reductive success. Cheetahs have high heterozygosity. Cheetahs have a large gene pool. Or genes have a small gene pool. So what could be the reason for that? Obviously, it nothing to do with poor reductive success. Why? Because it says here it has been discovered that organs can be transferred between any two individuals without rejection. So it has nothing to do with reproductive, and it's definitely nothing to do with the poor. Okay, next, cheetah have high heterozygosity. Now, when we say that, we're just talking about them having different frequencies. If we have different frequencies of alleles, or different alleles, that means they're more different. So that means if they're more different, that means more likely they're not going to exchange the organs. See, the organs have to be very similar in order to exchange. And hetero means they're very different. Very different will kill the organ, so no. So now we're stuck between a large gene pool or a small gene pool. Which one would be the individuals without the rejections of the organs? If we say a large gene pool, most likely there's going to be more variation, right? Because there's going to be much more different types of alleles. Now, if it's a small gene pool, most likely they're all going to be what? The same, because it's a small gene pool. So the cheetahs will pass with other cheetahs who are very similar to each other, and a small pool means they're almost exactly the same. So the answer is D. Do not think a large gene pool means, oh, more of them, that means likely. No, the more it is, the more variation will happen. The smaller it is, the less variation. So obviously D is the answer. And when I say less variation, that means they're more likely to be the same. Next, many commercially produced bananas are triploid instead of diploid. So that means instead of 2N, there are 3N. Okay. The nucleus of the triploid cells has 3 sets of chromosomes. So this right here, it has 3 sets. What is the defect of triploidy? Now, this is about polyploidy. So could be, we're talking about bananas, so we're talking about plants. And we need to remember what plants have to do with polyploidy. One of the things is they can be very large, and the other thing is they can live without seeds. So that's a good thing for commercial, is get rid of the seeds and make them large. So seeds are larger? Nope. Chromosomes cannot pair in meiosis. Sexual reproduction is more rapid. Mitosis cannot occur. Mitosis can occur because, again, you can go from making 3N the 3N, so not this. Sexual reproduction is more rapid. No, you can't. Remember, when it's odd, that's it. If it's odd, it cannot reproduce, so it's off. So the only one you have here, chromosomes cannot pair in meiosis. That is true, because homologous is always about pairing. So if you get, let's say, let me do this here. Let's say if you only have 3N, right? So the first chromosome will work with the second one, but what about the third? He's like stuck. He cannot pair. It's empty. It's not there. So the right answer is B. So remember, anything that is odd cannot reproduce because it has to be an even. So that's the kind of questions, like I said. Remember what everything is about: disruptive, directional, stabilizing, polyploidy, gradual, and punctual. These words that I just mentioned right now, write it down: destabilizing, directional, disruptive, gradual, punctual, and polyploidy. These are the most common questions when it comes to 10.3. If you understand these words and what the concept is behind them, you will answer every single question to 10.3. And this is pretty much it for this section. Thank you.